Good afternoon, everybody, and welcome to this IAC Acoustics webinar. My name is Ted Marquis, and I'm here to present to you the IAC Macrodyne Hardliner Reverb Rooms. Here is my information. Should you have any questions or would like additional information, you can email me at tmarquis@iacacoustics.com or visit our website. For more additional information, I'll have my contact information up at the end of the slide. And here's some brief information about me. So I hope today finds everybody well, given the COVID-19 pandemic. I appreciate you joining, and I look forward to speaking to you today about the Reverb Rooms by IAC Acoustics. So we'll kind of cover some basic topics here, IAC Acoustics, some company information. We'll go over kind of what is a reverberation room, and we'll go over some construction details, as well as we'll speak specifically about the room volume and frequency cutoff, and then we'll go over some features and options. We'll have some different pictures and things throughout. So let's get started. So IAC Acoustics was established in 1949 by Martin Hirschhorn in the Bronx, New York. Has been a great company ever since. We are now part of the Catalyst Acoustics Group, being our parent company, and we are an elite group of acoustic, seismic, vibration, and noise control companies that together offer the broadest portfolio of noise control solutions in the market today. Also listed on this slide is our sales team at IAC Acoustics, with Tom Hines, myself, Dan O'Brien, and Darren Riley, and Nick Smith, all with varying amounts of years in the acoustics industry. So we're here to serve you. So what is a reverberation room? A reverberation room can be considered the opposite of an anechoic room because its boundaries will reflect rather than absorb incident sound energy. Reverberation rooms are designed for the determination of sound power output of noise sources, transmission loss of partitions, insertion loss of silencers, response characteristics of microphones, and random incident absorption coefficients of materials. They are also used for high-intensity noise level fatigue testing of aircraft, space vehicles, or other equipment. The purpose of a reverberation room is to create a highly diffused acoustical measurement environment, defined as a sound field in which the acoustical energy flows equally in all directions. A reverberation room must provide sound isolation against extraneous noises and an environment which can be temperature, pressure, and humidity controlled. The reverberation room, which all acoustical test facilities may appear to be the least complex, is the one often constructed incorrectly. The achievement of the required room ambient sound levels, sound absorption coefficients, appropriate reverberation times, correct volumetric ratios between room and test object requires the necessary acoustical experience and know-how. Contrary to rectangular designs used today, it was once believed that skewing of the walls and ceilings was necessary for reverberation rooms to achieve a diffused field. However, excellent results are being obtained with rectangular construction. To obtain good diffusion with any room configuration, stationary diffusers and/or moving vanes may be needed to provide an interchange of sound energy for uniform distribution of room resonances. The general concern for a quieter environment at home, in the office, in plants and schools and hospitals, inside and outside motor vehicles, has resulted in a large number of rating standards, criteria, government regulations for the control of noise. These have been developed for several industries by institutions such as ASTM, ANSI, ASHRAE, IEEE, ISO, and others, most preceding the current concern with noise pollution. Hardliner rooms are often specifically designed for acoustic labs in their testing methods. You can see in the picture here we have a representation of ASTM E90, ASTM C423, ASTM E596, to mention a few. E90, which is the airborne sound transmission loss of building partitions, whereas this test measures sound isolating properties of a partition by comparing the sound energy in two adjacent chambers separated by the test specimen. Broadband noise is generated in one chamber, and sound pressure levels are measured simultaneously in both. After correcting for room losses and the area of the sample, the difference between the two sets of data is the transmission loss in decibels for each test frequency. A single number rating called Sound Transmission Class, or STC, is also calculated. The rating is derived by fitting the transmission loss data to a set of standard performance curves. ASTM C423 is the sound absorption and sound absorption coefficients by the reverberation room method, where sound absorption in a random incident sound field requires the testing of large samples in a 10,000 cubic foot reverberant chamber. Reverberation times for both the empty room and the room with the test sample in place are measured over a range of frequencies. The sabins of absorption attributed to the sample are divided by the sample's phase to get the sound absorption coefficients at each frequency. A separate standard, ASTM E795, covers the mounting of the test samples. ASTM E596, the noise reduction of sound isolating enclosures, is a standard method used to rate the performance of sound isolation enclosures used in audiometry, recording, and music practice. This test compares the inside and outside sound levels when the enclosure is exposed to random incident sound in a reverberation chamber. Microphone positions are selected to record average levels consistent with the purpose of the enclosure. Noise reduction is the difference between the outside and inside sound levels in each 1/3 octave band. Reverb rooms are also designed for the acoustical testing of several things we use every day, such as home appliances, speakers, fans and blowers, pumps, HVAC equipment, including chillers and AC units, automotive materials such as headliners and carpeting and carpet padding, and also ceiling material manufacturers. In this slide here, we show what we call a CAC room, or ceiling attenuation class, whereby two adjacent reverb chambers, modularly constructed of the hardliner IAC Macrodyne system, has an open ceiling across both chambers, whereas the manufacturer of the material inserts the ceiling material and then tests the relevant attenuation between the two chambers through the ceiling material. Now we'll talk a little bit about room construction. For a reverberation room to perform correctly, careful consideration has to be given to several factors, which may include things like interior volume, the room dimensions in relationship to the size of the test object, the interior working space, the lowest frequency band of interest, inside acoustic ambient, the noise reduction required from outside to inside, vibration isolation requirements, any ventilation requirements that are silenced to maintain the acoustic integrity of the system, doors and access plugs, lighting and other electrical systems, and any structural requirements. IAC Macrodyne reverberation rooms are designed not only to fully satisfy reverberation requirements, but also meet specific interior acoustic sound levels and other environmental requirements. This is accomplished by single wall and double wall structures, standard and special ventilation systems, and vibration isolators to supply the required noise reduction. In addition, rooms are tailored to provide suitable working spaces. So we'll consider the size and types of doors and lighting and climate controls appropriate to the work intended. And this is all done in a modular format. All these elements are assembled with an engineered modular structural framework that ensures the overall integrity of the reverberation room. With the IAC Moduline component system, virtually any size room can be created. And here are some of the benefits of the modular enclosure system. Noise from equipment within the enclosure cannot escape, and noise on the outside of the enclosure cannot enter. We will use a set of performance-rated panels, floor systems, vibration isolation systems, our IAC noise lock doors and windows, and ventilation systems that are required to maintain the acoustic integrity of the whole enclosure system. Enclosures are airtight so that we prevent any small holes or leaks, because that will compromise the performance. And the modular design with acoustic details is not only simple and reliable in installation format, but it does allow for reconfiguration and actually moving or relocation of the chamber should that be desired. IAC Macrodyne reverberation rooms are designed and constructed to meet current standards. These standards generally require that the room be large enough and have a low total sound absorption to provide an adequate reverberant sound field for all frequency bands of interest. Additionally, modal density, or more than one mode or frequency, or the number of resonant modes per unit of frequency is taken under consideration. For most applications, we recommend the preferred minimum volumes, which are a function of the low cutoff frequency as shown in the table on the slide. Also, it is recommended that the volume of the test equipment not be larger than 1% of the room volume. So you can see clearly for large pieces of equipment or very low cutoff frequencies, larger rooms are required. As you go from 125 hertz octave or 100 hertz 1/3 octave from a 200 meter cubed room and dropping that to a 70 meter cubed room for 200 hertz 1/3 octave. That can be a big difference. Also in this picture is an example of a setup where the company that manufactures hospitality type AC units is testing the transmission loss value of those units while in the wall system. Room proportions should also be selected to avoid unequal spacing between the frequencies of the normal modes or full wavelength of the room. To achieve this condition, it is recommended that the ratio of any two dimensions does not equal or closely approximate an integer. Suggested room dimensional ratios are listed in this table here. So where we do have some standard room sizes for a particular cutoff frequency and their volumes, should we have to customize a design for you, we would consider these ratios in our design criteria. The sound absorption coefficients of a reverberation room surface must help ensure a satisfactory reverberant field and minimize the effect of source positioning on measurement accuracy. Consistent with current standards, the Macrodyne reverberation rooms have an average sound absorption coefficients of less than 0.06 for the frequency range from 125 to 8,000 hertz. However, in a lower frequency range, additional absorption or bass traps is usually desirable to increase the bandwidth of normal modes of the room. The upper limit of this frequency range is given in the following relationship, where the frequency would equal 2,000 over the cubed root of the volume. The highest value of the average sound absorption coefficient within frequency range of interest should not exceed 0.06. As you can see by the chart, the hardliner Modulin panel has been designed and developed to meet those requirements. Modulin hardliner modules meet these desired sound absorption characteristics as shown. The Macrodyne hardliner reverb rooms can be, as previously mentioned, either constructed as a single wall or a double wall. Single wall Macrodyne reverberation rooms are available with and without IAC vibration isolated hardliner floors, depending on the degree of structurally transmitted noise required. Double wall Macrodyne reverberation rooms are designed to provide optimum noise isolation with the hardliner noise lock components. These use double wall and ceiling construction within the inner room on its own IAC hardliner vibration isolated floor system. The outer room will rest on the building floor. However, where more vibration isolation is required, the outer shell can also be supplied with an Acoustafloat IAC floor. Some of the standard features that come along with the Macrodyne hardliner reverb room is the hardliner panel construction, double or single walled ceiling construction, IAC tranquil air ventilation systems, and also those can be coupled to building supply. We can offer interior lighting, tubular cable and power ports, the IAC noise lock door, IAC Acoustafloat floor for double wall rooms, and complete certification and commissioning tests. Some available options are self-contained air handling and ventilation systems, additional or large or oversized doors, while still meeting the acoustic requirements, access panels specifically designed for the customer's need or product, and we can also include the Acoustafloat floor for single wall rooms. This slide here is of some standard rooms that we do offer, from our smallest room, which is the type 201 for a 200 hertz cutoff frequency, and it has a volume of 2646 cubic feet or 74.9 meters cubed, to a type 212 with just over 10,000 cubic feet or roughly 300 meters cubed. These are all pre-configured rooms that are available and can be further discussed. Additionally, we offer pre-assembled or smaller chambers that can be built pre-assembled in our factory and shipped out ready to use. These can also be pre-certified in our factory. And that is the webinar, so I hope you enjoyed it. As a brief introduction to our IAC Acoustics Macrodyne hardliner reverb rooms. If you have any questions, please feel free to give me shoot me an email at tmarquis@iacacoustics.com. And if you'd also like to request a copy of this presentation, we can send that to you along with our acoustic test facilities brochure. Thank you and enjoy the rest of your day.